The next topic is something very close to my heart. I'm sure it would be very close to your hearts too. We have got Vinay, who is the co-founder and CEO of Arya.ai. A very interesting topic, machine learning observability for mission critical AI to make AI explainable, safer and acceptable. Vinay is a graduate of IIT Bombay. He is the founder as well as the head of research for Arya.ai. Lot of good experience with him, and we hope to learn from him today.
Hey, good morning, guys. So I'll skip the introduction of Arya.ai. So I'll just conclude in a one-line statement what we were doing in the last decade. So we started off to deploy deep learning, and we tried to democratize deep learning in the last almost 10 years. We were one of the first deep learning startup out of India. Over the course of deploying AI in very sensitive use cases, like in financial services, one of the things that we realized or we believe is required is explainability, auditability, and accountability, right? In short, model alignment, for example. So today, it's became quite easy to build any AI ML model. So I can take about 10 minutes and build an ML model. The question is that model qualified to go production, for example? So that's where you will have a lot of questions from a usability standpoint. So that's where ML Observability comes into play. Next slide. Yeah, so the nirvana stage for insurance is where everything is automated. All decisions are non-biased, and all decisions are available and provided to customers across backgrounds, right? And then you have a regulatory framework which supports that, and a regulatory framework which will enable the ecosystem to grow. So for this to happen, that was the vision for 2040 given by Arya.ai, right? Insurance for everyone, for example. So how can that happen if it is a completely process-driven kind of systems today? I mean, it's good that you have a digital flow, but imagine that currently you may be serving, let's say, 10 million customers. Now, what kind of systems do you need if you want to serve from 10 million customers to 500 million customers, to a billion customers, for example, a billion and a half? So do you think it would still be driven by 100 people, 1,000 people sitting in the back, taking decisions across these processes? And how do you price it, right? Because out of this 1.4 billion population in India, pick up any segment with a band of 0.1%, you will find 10 million people for that bucket, right? So how do you price that, for example? So this is where AI is absolutely required. There is no other way. You could think of any other solution, but there is no other solution. You cannot have a fixed benefit product for everyone. Even then, your claims will get leakage and all of that, right? That's why AI is kind of critical for the success of insurance across users. Next slide. But look at the evolution of AI, right? So it started with a simple rule-based systems or maybe complex rule-based systems. And then you have classic AI ML, which is primarily machine learning systems like XGBoost, tree-based models and all of that. And then you have advanced AI ML, which started from 2014 to 2020s onwards. In next 3-5 years, we are expecting a weak AGI, some kind of AGI that can do everything on its own, define the tasks and everything. And then in few years, we are expecting AGI. But if I ask any insurer in terms of, everybody claims that they use some kind of AI, but majority of the times behind the hood, it's rule-based systems. Underwriting, about 80-85% of the processes today is underwriting rule-based driven systems. Fraud, trigger-based systems. Claims, policy-based rules, process-based rules, and then rules are used to evaluate the process. Rules are good starting point, but the next question is AI, right? Now, if AI is so much in demand, why are we not deploying it? Why is it not 100% deployed in the market today? Why is it not used by everyone today, for example? Next slide. There are a lot of challenges to deploy AI. As I said, it's quite easy to build. Any AI ML model I can build maybe in 10 minutes, 15 minutes, meaning random AI ML model. Very advanced model takes about 3 months, 2 months, depending on the data, depending upon the problem maturity, for example. While the model is built, the next thing is it usable? Is it acceptable, right? So that's where user will get stuck a lot of times. Because again, majority of the times, the process owners who are experts in the process. Now, we are introducing a technology that they are not aware about. In fact, the guys who built it themselves were not aware about, right? There are a lot of challenges to deploy AI, starting off with black box models. Meaning, if I come up and say that I have a very advanced AI ML model, let's take LLMs, for example. I use LLMs to underwrite. Now, the question is black box. I cannot understand how these LLMs have taken the decision, right? If you cannot understand, then you cannot use. So black box nature of these models is one of the biggest challenge. Second is regulatory guidelines, meaning this is one of the questions that we, or at least challenge that we continuously face when we go to an insurer with a revolutionary concept. Maybe insurer nahi manega, sorry, IIA nahi manega, regulator nahi manega, or there is no clarity on some of these AI usage challenges, for example. Third is the lack of training data, meaning not everybody would have enough training data to build these models. Fourth is lack of knowledge on architecture. As I said, this technology itself is very new. Everybody can claim that I'm an AI expert and build something for you, but that's where it gets challenging. Next slide. LLMs, I was taking that as an example, hallucination, black box, I can hack an LLM and get the training data out of it. These are the reasons why people are not using, regulatory industries are not using LLMs at this point of time. Next question. Sorry, next slide. And even if I build an AI ML model, this is the other challenge that we have seen. People imagine that AI is magic. Once I build it, the magic works irrespective of my intervention. But in reality, AI can fail more often than your software. So software is actually more stable. When I build an application, it works majority of the times unless someone puts a hand and intervenes that. But in ML models, it fails on its own. It's a trend that is there in the data. It's a trend that is there in the ML models itself. It can degrade quite quickly, or it can degrade quite slowly, but it will degrade, and the performance is not guaranteed. Then how are you monitoring these things? For example, imagine that I build an underwriting AI model, and 80% of my business is underwritten by AI. And what if it fails? Do you have business continuity risk that is managed? Are you doing enough model risk management today? Those are the challenges that people have not fully thought about at this point of time. So that's the second reason. Next slide. Black box nature, as I said. And again, when people think about explainability, people always say that feature importance as an explainability. But is it understandable by everyone? You have different users in the end. You have actuaries, you have underwriters, regulators, data scientists, and the customer themselves. So you have to explain it to all these stakeholders. How do you explain these models, how they have worked, that is understandable by all these stakeholders, right? That's another challenge. Next slide. If you don't do this properly, meaning you could still deploy these models and then realize the risk in production. As long as you have managed risk very well, the risk outcome could be controlled. If you have not done that, it can create business continuity risks. For example, there is a startup called Zillow, which does price prediction using AI/ML models. They didn't track the model drift in production, so the price was in reality X. Model prediction was about 50%, 60% more than the reality, because the trend was a little different, because you may not have all the training data at that moment, right? Then how do you give enough feedback to make it understand that, this is what it's happening? Next slide. Yeah, so that's why you need a guardrail or a layer around your models that can tackle all of these problems. That's what ML Observability framework is. Next slide. So that's what we have been working on since last 3 years. Last 10 years, we have been trying to deploy AI. Last 3 years, we were trying to control and prevent Skynets in our models, for example. So one of the products that we created recently is called Arya.ai. It's an ML observability platform. It has 2 key components, model diagnosis and model prognosis. So model diagnosis tells me what all is wrong in my model. Model prognosis tells me how can I fix it and what are the ways I can fix it. Next slide. So this Arya.ai has different components: ML explainability, monitoring, auditing, and prognosis components. Meaning you can build a model. Let you, meaning the data scientist, focus on building the models. The framework can tell them on how to explain these model prediction, how to understand these model predictions, for example. Next slide. So for us to do this, we had to create new techniques to explain this. Like, if you know us, we use deep learning a lot. So deep learning is one of the advanced technologies. They are one of the hardest approaches to explain the decision, for example. So we created a new explainability algorithm called backtrace, which is now patent pending. We filed the patent in 2021, so we can actually understand what's happening inside a neural network better than the open source methods like Sharp or Lime, for example. That actually is helping us for majority of our products today. So meaning when we do underwriting decision, we can explain how the model is working. When we do claims automation decision, we can explain how it is working. When we do fraud detection, we can tell you why the model thinks the transaction is a fraud, for example. Next slides. We also have something called decision tree path. Irrespective of the models, we can say, what happens if some X parameter change, how does the model react and everything. Next slide, you can continue. Compared to your traditional ML ops, where you may not get enough information from your model prediction, so Arya.ai can give a bunch of information in real time as an API. So you can plug in your model to Arya.ai and start getting all this explainability as a simple API output. Next one, you can skip through this. Drifts, so one new concept that we are introducing is something called synthetic AI. I talked about model alignment, right? Let's say my trend has changed very recently. How can I give that feedback to my model? You could do retraining, but the problem is your training data is 1,000,000, whereas your today's data is 100. So how can you give that feedback which is effective enough to your model? Or the model is acting in a different manner. Let's take LLMs, for example, or AGI, for example. So how do you make sure the alignment is happening with the business decisions? One of the concepts that we have is something called synthetic AI, meaning create a lot of synthetic simulated training data basis on your realistic training data so that you can use it to retrain the model or configure your model or do the model alignment itself. So this we do off the shelves. You can simply plug in Arya.ai to your data and create all of these components. Next slide. Next slide. Yeah, our vision is let the industry figure out how to build AI. We figure out how to control it. We ensure there is no Skynet in the models. And make sure that is usable for across stakeholders. It could be sensitive industries like healthcare, for example. I cannot have a black box doctor, or I cannot have a racist doctor also, right? So we ensure those things are not there in your AI/ML models. We ensure there is alignment. Let's say in the next 5 years there is an AGI. We would be the layer that around that AGI to ensure it's not acting erratic, it's stable. It's aligned with the user alignment requirements. So that's the goal for Arya.ai. That's what we are working on. We have solved majority of the problems today. We are about to solve the remaining problems in the next few years. Hopefully, we will become that protection layer around AI and ensure there is usability around this. And when regulations comes in, which is what we are telling regulators as well, you should start regulating it. As I said, business continuity risk, right? You're using a component which you do not understand, nor doing risk management well enough. That has to be given as a notification to all the users. When regulations comes in, which is quite soon, is what everybody is saying, then this layer becomes really important across your users. Or for self-governance, meaning some people are not waiting for the regulations to come in, so they want to do this by themselves. For them, it's again a plug-and-play box that is delivered today. So that's what Arya.ai is, and ML Observability is going to be really important as you start hearing about AI going forward. That's all. So happy to take in if you have any questions, guys. Thank you very much.